Okay, the idea that we're looking at in this particular triangle is that D is the centroid of the triangle. And for us to be talking about a centroid, these heights have to be reclassified as medians because they are. That's why equilateral triangles are really special, is because the heights are a lot of things. Median is just a line segment that's drawn from one vertice to its midpoint. If we draw all three of them, creates this point of concurrency. This point of concurrency is a centroid. It just so happens that the centroid is also called a bunch of other things in an equilateral triangle. What is really cool about a centroid is that when you draw a centroid and you construct it carefully, you can find the balancing point for any triangle, not just an equilateral triangle, but for any triangle. So, for instance, if I would put a pencil at point D, I should be able to balance the triangle on my pencil at point D. Now, you would probably want to use a little bit harder stock paper to do this, but it's a pretty cool consequence of what a centroid is. Another pretty cool consequence is if you look at all these, what we've now learned are apophthegms, all the apophthegms are exactly half the length of the remaining part of the line segment. And the remaining part of the line segment is something we're going to define as a radius of this equilateral triangle. Okay? So the apothem creates the radius, or I'm sorry, the centroid creates, in this case, the radius of this equilateral triangle and the apothem. And that's created because those are medians. And that point D, which we know is lots of things, is the centroid of this polygon, which is the gravitational center of this triangle.